Hello, today's class is on relative measures of skewness. Okay, the absolute measure of skewness, uh, which is expressed in relation to some measure of dispersion, is called relative measure of skewness or coefficient of skewness. Relative measure of skewness gives us pure number which is independent of the units in which the values of distribution are expressed. This enables us to compare and interpret the results of two or more distributions whose values are given in different units. There are four important methods of relative measures of skewness is given. They are the Carl-Pearson coefficient of skewness and the Bowles coefficient of skewness, the Kelly's coefficient of skewness, lastly the measure of skewness based on moments. However, due to time constraint, we are discussing only two methods here, and that is Carl Pearson coefficient of skewness and Bowles coefficient of skewness. Okay, according to Carl Pearson, skewness is calculated with the help of formula, and that is Carl Pearson skewness, the SKP is equal to mean minus mode by standard deviation. This is the first formula given by Carl Pearson when mode is defined. Okay. Characteristics of Carl Pearson's coefficient of skewness is first character is skewness is 0 for a symmetrical distribution. You don't find any skewness for the symmetrical distribution. In a positively skewed distribution, the value of mean is greater than mode. Okay, when positively skewed distribution, the mean, okay, value of mean is greater than mode. In a negatively skewed distribution, the value of mode is greater than mean. Okay, it is vice versa, right? Theoretically, fourth character is theoretically this measure varies with the within the limits of plus or minus 3. Okay, which is a rare phenomenon in the real life. Okay, it won't be plus or minus 3 in the real life. Usually it varies in between plus or minus 1 only. Okay, uh, the formula which we have discussed, that is SKP is equal to mean minus mode by standard deviation, is not useful to calculate the skewness for a mode is ill-defined or bimodal multimodal frequency distribution. Hence, Pearson has suggested another formula, that is SKP is equal to 3 bracket of mean minus median by standard deviation. This is the second formula that is given by uh, Carl Pearson. Based on this formula, formula is based on relationship of different averages of a moderately asymmetrical distribution. In such distribution, mode is equal to 3 median minus 2 mean, mode is equal to 3 mean, median minus 3 mean plus mean, mode minus mean is equal to 3 bracket of median minus mean is another. These formulas are derived from the second formula that is given by Pearson. Okay, if we know the value of mean and mode, okay, mean minus mode, we need to submit the same in the formula, and the SKP is equal to 3 mean minus median. If you know the median and mean, you will get the SKP without mode also. That is SKP is equal to 3 bracket of mean minus median by standard deviation. This is the third equation that is given by Carl Pearson. Now we will consider one example from continuous series for the better understanding of the Carl Pearson's coefficient of skewness. That is calculate Carl Pearson's coefficient of skewness from the following data. He has given classes 0, 5, 5, 10, 10, 15, 15, 20, 20, 25, 25, 30, 30, 35, 35, 40, 40, 45, 45, 50. And he has also given the frequencies, the number of workers. Okay, that is 4, 6, 10, 20, 30, 60, 30, 20, 20, 10. This is the information that is given by the examiner, and now we need to solve. And the information given by the examiner is indicated in the red color, and the solution is we have taken the black one, right? Here, first we need to find out the mid value for the given wages. That is x is given 0.5, upper limit plus lower limit by 2 is, will get the mid value, that is 0 plus 5, 5 by 2, 2.5. Then the second class 15 by 2, 7.5. Third class 25 by 2, 12.5. Fourth 35 by 2, 17.5. 45 by 2, 22.5. 55 by 2, 27.5. 65 by 2, 32.5. 75 by 2, 37.5, 85 by 2, 42.5, 95 by 2, and that is 47.5. These are the mid values we will get. We need to consider the step deviation for the calculation of continuous series. Okay, a coefficient of correlation in a continuous series. Hence, m minus a we will take assumed mean, and we will consider some common factor. M is as we got 2.5, 7.5, 12.5. M minus a assumed means here I am considering 22.5. Okay, m minus 22.5 by common factor is taking I am 5. Hence 20 22.5 minus 22.5 is equal to minus 20 by 5 is equal to minus 4. Okay, 7.5 minus 22.5, which is equal to 15. 15 minus 15 by 5 is nothing but minus 3. 12.5 minus 22.5 by 5 is equal to minus 10 by 5, which is nothing but minus 2. 17.5 by 70.5 minus 22.5, which is equal to 5. Minus 5 by 5 minus 1 you will get. 22.5 minus 22.5 is equal to 0. 27.5 minus 22.5 by 5 is nothing but 5 by 5 1. 32.5 by 22.5 minus 5 22.5 by 5 is equal to 2. 37.5 minus 22.5 by 5 is nothing but 15 by 3 3. 15 by 5 3. 42.5 minus 22.5 by 5 is nothing but 20 by 5 4. That is 47.5 minus 22.5, that is 25 by 5 is nothing but 5. Now what you got d dash need to be multiplied with the f given frequency in order to get the fd dash. Okay, that is sum of the product of frequencies and deviations is required to submit in the formula. Okay, in order to get the value, that is fd dash, that is minus 4 is the d dash value for the first class, and f is 4. 4 into minus 4 minus 16, 6 into minus 3 minus 18, 10 into minus 2 minus 20, 20 into minus 1 minus 20, okay, 0 into 30 0, 60 into 1 60, 30 into 2 60, 24 into 3 72, 20 into 4 18, 10 into 5 50. If you add all these, the product of frequencies and deviations, you will get sigma fd dash, that is 248. And now we also require f into d square. First we need to uh, find the d square. D square means minus 4 into minus 4 minus plus 16, minus 3 into minus 3, that is plus 9, minus 2 whole square, that is minus 2 into minus 2, 4 minus 1 into minus 1 4, minus 1 into minus 1 1 plus 1 0, 1 into 1 1, 2 into 2 4, 3 into 3 9, 4 into 4 16, 5 into 5 25. These are the d square values. If we multiply these values with the corresponding frequencies, we will get the fd1 square, fd dash square, that is 16 into 4 64, 9 into 6 54, 4 into 10 40, 1 into 20 20, 0 into 30 30, and 1 into 60 60, 4 into 30 120, 9 into 24 216, and 25 into 10 okay, 9 into right, 9 into 24 216, 16 into 23 20, and 25 into 10 250. If you add all these, you will get the fd dash square, that is sigma fd dash square is equal to 1144. As we require x bar, okay, that is a plus sigma fd dash by n. We know that a is equal to 22.5, sigma fd dash is equal to 48, n is equal to 14, c is equal to 5. Substituting the values, you will get 22.5 plus 248 by 214 into 5, which is equal to 22.5. Okay, 22.5 plus 580, 5.80, that is 28.3, you will get as answer to 28.3. Now sigma, we need to calculate standard deviation, that is sigma, small sigma is equal to under root fd dash square by n minus fd dash 1, okay, fd dash by n whole square into c. We know that fd dash square is equal to 1144 and fd dash is equal to 48, n is equal to 14, c is equal to 5. Substituting the values in the formula, you will get sigma is equal to under root 1144 by 214 minus 248 by 214 whole square into 5, that is under root 5.35 minus 1.34 into 15, and the under root that is equal to 4 into 1 5, that is 15, that is 2 into 15 is equal to 2 into 5, that is equal to 10. 2 into 5 is equal to 10, right? We got the answer. 2 into 5 is equal to 10. Now we need to make analysis table in order to find out the grouping table in order to find out the mode. In order to make the grouping table, first column is consider the classes, and in the second the column, that is called column 1, we should take the frequencies. If in order to get the column 2, that is column 3 of column 2, named it column 2, we need to add two frequencies. Okay, pair the frequencies in two twos, that is 4 plus 6 10, 10 plus 20 30, 30 plus 60 90, 30 plus 24 54, 10 plus 20 plus 10 30. In order to get the third column, you need to skip the first frequency and leaving the first frequency add 2 that is 6 plus 10 16, 20 plus 30 50, 60 plus 30 90, 24 plus 20 44, and remaining 10 is that won't have any pair, hence that should be left. And in order to get the fourth column, we should add in 3 threes, that is 4 plus 6 10, 10 plus 10 20, 20 plus 30 50 plus 60 110, 30 plus 24 54 plus 20 74. These are the fourth column values. In order to get the fifth column values, leave the first one and add 3 threes. 6 plus 10 16, 16 plus 20 36, 36. You have 30 plus 60 90 plus 31 20, 24 plus 20 44 plus 10 54. This is the column. In order to get the sixth column, you need to leave first two and add remaining three, that is 10 plus 20 30, 30 plus 30 60, 60 plus 30 90, 90 plus 10 24. We will have 114 and the remaining two only, hence we don't have three pairs, we leave the thing. Based on this, we need to make a analysis table. Analysis tables, okay, analysis table is based on the grouping table, right? In the first column, we will take how many columns, numbering, which number occurs more number of times. In the first row, we will take column class intervals, that is 0 5 5 10 10 15 15 20 20 25. Okay, and in the first column we will have the column numbers. If you observe the grouping table, the column which occurs, that is highest frequency having number in the first column is 60, that is 25 30 class, hence put 1 there in the 25 30 class. In the same manner, if you observe in the second column, you will find the class which occurs 20 25 25 30, more number of times, put 1 there. And in the if you go to the third column, you will observe 25 30 and 30 35 occurring more number of times. If you go to the fourth column, you will observe that 15 20 20 25 25 30 are occurring in more number of times, that is you need to put 1 there. And if you go to the fifth column, you will observe 20 25 25 30 and 30 35 occurring more number of times. If you observe sixth column, that is 25 30 30 35 35 40 occurring more number of times. Hence if you add all these okay according to their class occurrence in the class interval, you will find 13631, and that is 6 representing 25 30 class. That is the class. Okay, it is clear from the analysis table that mode lies in the class 25 30 because it is occurring more number of times, right? Now we use a formula to find the mode, that is mode is equal to L plus f1 minus f0 by 2 f1 minus f0 minus f2 into I, where we know that L is the lower limit of the modal class, that is 25, f1 is the 60, that is nothing but f1 modal class value, f0 the value of the frequency of the preceding class, and f2 is the frequency of the class before the model class, that is 30, f0 is 30 and I is equal to 5. Substituting these values in the formula, you will get mode is equal to 25 plus 60 minus 30 by 2 into 60 minus 30 minus 30 into 5. 25 60 minus 30 you will get 30 by 2 into 60 120 minus 30 minus 30 minus 30 minus 30 minus 60. Okay, hence 30 by 120 minus 60 into 5, 25, the same we will take, and plus 30 into 5 150 by 120 minus 60 60, 150 by 60 you will get 2.5, hence 25 plus 2.5 is equal to 27.5. Then now we'll find SKP by using these values. We got mode and mean, standard deviation, hence we need to substitute the same in the Karl Pearson's coefficient of skewness, that is SKP is equal to mean minus mode by standard deviation. Mean is 28.30, mode is equal to 27.50, and the standard deviation is equal to 10.015. Substituting these values in the formula, you will get SKP is equal to 28.30 minus 27.50 by 10.10, that is 0.80 by 10 is nothing but 0.08. Okay, 0.08. With this we know that the distribution is positively skewed with a very little degree of skewness, right? Next we will conclude another problem from inclusive method, that is 10 14 14 15 to 19 20 24 25 29 30 34 35 39, and number of workers is given 3 10 20 35 18 4. With this we need to solve the problem. This is given the information given in the examination. Okay, and we will need to solve this, right? We need to find out MB as we already discussed. Okay, as we have already discussed, lower limit plus upper limit by 2, that is here 10 plus 14 24 by 2 is nothing but 12. In the same manner we will get 15 plus 19 by 2 17, 22 plus 24 by 2 22, 25 plus 29 by 2 is 27, 30 plus 34 by 2 is 32, 35 plus 39 by 2 is 37. Okay, now we need to find the deviations m minus a by c, that is m is mid value minus a is nothing but assumed mean by c is nothing but common factor that we are taking for the purpose of easy calculation, that is m minus 22 by 5, that is 12. Okay, minus 22, you will get 10 by 5 is nothing but minus 2, minus 10 by 5 is nothing but minus 2, 17 minus 22, that is minus 5 by 5 is minus 1, 22 minus 22 is 0, 0 by 5 is nothing but 0, 27 minus 22 by 5, 5 by 5 1, 32 minus 22 by 5, 10 by 5 is nothing but 2, 37 minus 22 by 5 is nothing but 15 by 5 is 3. Now we need to multiply these deviations with their corresponding frequencies, that is minus 6 into 3 you will get minus 6 into minus 2 into 3 you will get minus 6, minus 1 into 10 you will get minus 10, 0 into 20, you will get 0, 1 into 35, 35, 2 into 18, 36, 3 into 4, 12. Okay, now in order to find out fd square, here d dash square, you will find first d dash square. D dash square is nothing but 4 minus 2 into minus 2, 4, minus 1 into minus 1, 1, 0 into 0, 0, 1 into 1, 1, 2 into 2, 4, 3 into 3, 9. These are the square values are multiplied with their frequencies. That is minus 4 into 3, 12, and 1 into 10, 10, 0 into 20, 0, and 1 into 35, 35, 2 into 8, sorry, 4 into 2 whole square, hence 4 into 18, 72, and 9 into 4, 36. If you sum up these, that is the fd dash square is equal to sigma fd dash square is equal to 165, sigma fd dash is equal to 67. With this we will find the mean first. X bar is equal to a plus sigma fd dash by n into c. This is the formula, and here we know that a is equal to 22, sigma fd is equal, dash is equal to 67, n is equal to 90, and c is equal to 5. Substituting these values in the formula, you will get x bar is equal to 22 plus 67 by 90 into 5, that is 22 plus 3.72. If you multiply 67 with 5 and divide by 90, you will get 3.72. Then 22 plus 3.72 is nothing but 25.72. Now we need to calculate the standard deviation, that is sigma is equal to under root sigma fd dash square by n minus sigma fd dash by n whole square into c. Sigma fd dash square is equal to 165, sigma fd dash is equal to 67, n is equal to 90, c is equal to 5. Substituting the values in the formula, sigma is equal to under root 165 by 9 minus 67 by 90 whole square into 5. That is 165 by 90 is nothing but 1.83 minus 67 by 90 is 0.744 whole square into 5, which is equal to 1.83 minus 0.55 into 5. Under root 1.28 into 5 is equal to 1.13137 into 5, which is equal to 5.6558. Okay, next we'll find the grouping table for the same value. Grouping table, in order to find out the grouping table, first column we will consider the class intervals, and the second column we will take the frequencies that can be named as column 1, and we have 3, 10, 20, 25, 18, 4 frequencies to their corresponding classes, and we need to add 2 twos, okay, and get the column 2, that is 10 plus 3, 13, 20 plus 35, 55, 18 plus 4, 22 will be the column 2. And in order to get the column 3, we need to leave first frequency and add 2 twos, that is 10 plus 20, 30, 35 plus 18, 53. Only we have one left, that will leave. And in order to find out fourth column, we need to group 3, 3, 3 plus 10, 13 plus 23, 33, 35 plus 18 plus 4, that is 57. Okay, 22 plus 35, 57. We have only column 4 because we don't have more frequencies. With the column 4, okay, grouping table will be concluded. Next, based on this, we'll make analysis table. In the analysis table, in the first column we will take column numbers, and in the first row will have class intervals. Okay, corresponding to the column numbers, the number class which occurs more number of times will be put considered. Okay, giving 1. Right, in the 25, 21, the 25, 29 class occurs more number of times in the first column, that is 35 times it occurs. In the second column, that is 55 is the number which occurs more number of times, that corresponds to 20, 24 and 25, 29. In the third column, 53 occurs more number of times, that corresponds to 25, 29 and 30, 34. In the fourth column, 57 occurs more number of times. 57 frequency is that which corresponds to 25, 29, Okay, and 30, 34, 35, 39 classes occurs more number of times, hence we need to put 1 in the respective column. If you add all these, you will have, okay, 1 4 2 1. 4 corresponds to 25 and 29 class. It is clear from the analysis table that mode lies in the class 25 29, the class boundaries of which 24.5 29.5, because it is given in the inclusive method, and we need to convert it to exclusive method by making 0.5, subtracting 0.5 from the lower limit and adding 0.5 to the upper limit. Now the mode formula is there, that is L plus f1 minus f0 by 2 f1 minus f0 minus f2 into I. We know that L is equal to 24.5, F1 is equal to 35, F0 is equal to 20, F2 is equal to 18, and I is equal to 5. Substituting the values in the formula, mode is equal to 24.5 plus 35 minus 20 by 2 into 35 minus 20 minus 18. Okay, if you look at the PPT, you will find this into 5. 24.5 plus 15 by 70 minus 38 into 5. Okay, that is 24.5 plus 75 by 32, which is equal to 24.5 plus 2.34 is equal to 26.84. Okay, now we are in a position to calculate the coefficient of skewness by using the Carl-Pearson's coefficient of skewness formula, which is equal to SKP is equal to mean minus mode by standard deviation, that is mean is equal to 25.72, mode is equal to 26.84, and standard deviation is equal to 5.6568. Substituting the values in the formula, you will get SKP is equal to 25.72 minus 26.84 by 5.6568, which is equal to minus 1.12 by 5.6568 is equal to 0 minus 0.198. Thus the series is negatively skewed. We will conclude with the results, right? Next, calculation of coefficient of skewness. He has given that number of workers is 120, which is given in this is okay. Information is given based on that without taking more into consideration. We need to calculate, that is and the following facts related to the relate to the workers of a factory before and after the settlement of an industrial dispute. Comment on the gains and losses from the point of view of workers and management. He has given before the settlement of dispute and after the settlement of dispute. Number of workers are 120 before the settlement, and after the settlement 117. Mean wages in rupees is given 90 and 95. Before settlement is 90, after settlement 95. Median wages before the settlement is 96, after settlement is 90. Standard deviation in before the settlement is 6 and after the settlement is 5. Okay, a solution we will consider on the basis of information given. We can make a few comments. First, we will compare the total wage bill and comparison of wage bill with if we compare total wage bill, the total wage bill before settlement dispute is 120 into 90, 10,800. Total wage bill after settlement of dispute is 177 into 95, and that is 117 into 95. Okay, 117 into 95, and that is okay, that is 11,115. Okay, 11,150. If you see, it is clear that the total wage bill after the settlement of the industrial dispute has gone up to rupees 11,115 from 10,800 before the settlement, but the number of workers has decreased from 120 to 117. Thus we can conclude that it is a gain to the workers and loss to the management, unless the increased wages result in higher production, increased efficiency, it will be a loss to the management and gain to the workers, right? Next, we will compare the median wages. Okay, before settlement of dispute, 50% of the workers used to get wage above 96 rupees, and after the settlement they get only above 90 rupees, right? It reveals that the median wages are decreased. That is bad news for the workers and good news for the management, because they can reduce the costs, right? Comparison of variation, that is sigma by x bar into 100. Okay, coefficient of variation we are calculating, that is sigma is given, that is standard deviation, which is equal to 6, x bar is 90. Coefficient of variation before settlement of the dispute is 6 by 90 into 100, that is 6.67. Coefficient of variation after the settlement of the dispute is 5 by 95 into 100, that is 5.26. Since the values of coefficient of variation has decreased from 6.67 to 5.26, it can be concluded that the wages are more uniformly distributed after the settlement of the dispute. Okay, and before the settlement it is not so. It is uniform and consistent. After the settlement it is uniformly distributed. We will conclude with the variation. Okay, coefficient of variation. Right, now comparison of skewness. We will compare the skewness. It is SKP is equal to 3 bracket of median minus median by standard deviation. SKP before the settlement of the dispute, Karl Pearson's coefficient of skewness is mean is equal to 90, median is equal to 96, and SD is equal to 6. Substituting these values in the formula, that is SKP is equal to 3 into 90 minus 96 by 6, that is 90 minus 96 minus 6 into 3 into minus 6 but minus 18 by 6 is equal to minus 3. SKP after the settlement of the dispute is equal to mean 95, median 90, and standard deviation 5. Substituting the values from in the formula, SKP is equal to 3 into 95 minus 90 by 5, that is 15 by 5 is equal to 3. While the distribution before the settlement of the dispute is negatively skewed, the distribution after the settlement of the dispute is positively skewed. Okay, this reveals that the number of workers getting low wages has increased considerably, and that of workers getting high wages has fallen. This is despite the fact that the actual wage of workers has increased. With this, we will conclude based on the comparison, and we will take position of average. Position of averages. Mode is equal to 3 median minus 2 mean. Okay, mode before settlement is equal to 3 into 10, okay, 3 into 96 minus 2 into 90, that is 108. Mode after settlement is 3 into 90 minus 2 into 95, that is 80. Thus we conclude that after the dispute, concentration of individual wages in around a much smaller value than before, most of the workers get near about rupees 80 after the settlement as against rupees 108 before the settlement of the dispute, right? And we'll see Bowley's coefficient of skewness now. Bowley pronounced, okay, propounded an alternative method of relative measures of skewness, which is based on quartile deviation. Okay, quartiles are right. In an asymmetrical distribution, the quartiles will not be equidistant from the median. In a positively skewed distribution, Q3 will be far away from the median than Q1. On the other hand, in a negatively skewed distribution, Q1 will be far away from median than Q3. In such a case, skewness is measured with the help of the Bowley's coefficient of skewness formula. SKB we call it as bracket of Q3 minus median bracket close minus bracket of median minus Q1 by Q3 minus median plus median minus Q1, or we can write this as Q3 plus Q1 minus 2 median by Q3 minus Q1. This measure is also called the quartile measure of skewness, and the value of coefficient varies between plus 1 plus or minus 1. This is a realistic phenomenon that we have seen in case of Karl Pearson coefficient, which is plus or minus 3. That is not possible in real life. This method is usually useful, especially in open-ended distribution and also in case of distribution which contain extreme values. Extreme values. Okay. Now we'll consider one problem here for better understanding. Calculate Borlase coefficient of skewness for following distributions. That is, he has given marks, that is 0, 10, 20, 30, 40, 50, 60, 70, 80. Number of students are 10, 15, 8, 12, 30, 35, 20, 18 and 3. In order to calculate the coefficient of Bowley's coefficient of skewness, we need to calculate the cumulative frequency. The information given by the by the examiner is indicated with red color, and which we are calculating cumulative frequency are given in black color. Calculation of median. First, median for discrete series. This is given in the discrete form. Size of n plus 1 by 2th item, that is 151. N value is 151. 151 plus 1 by 2, that is 152 by 2 is nothing but 76th item. 76th item will lie in the okay. 76th item will lie in the cumulative frequency of 110. Okay, the corresponding figure, that is x is 50, hence the median is 50. Calculation of quartiles. Q1 is equal to size of n plus 1 by 4th item, that is 152 by 4, that is 38th item. Size of 38 item, 38 item will, if you look at the cumulative frequency 45, the corresponding value will be the 30. Okay, the corresponding x value will be the 30, hence 30 will be the median. Q3, if you find out Q3, size of 3 into n plus 1 by 4th item, that is 3 into 152 by 4th item, 3 into 38 is equal to 114th item, that is size of 114th item in the cumulative frequency lies in the 130 of the cumulative frequency, hence the corresponding class is 60, hence the Q3 is 60. Calculation of Bowley's coefficient of skewness is nothing but SKB is equal to Q3 plus Q1 minus 2 median by Q3 minus Q1. As all we know these figures, Q3 is equal to 60, Q1 is equal to 30, median is 50. Substituting these values in the formula, SKB is equal to 60 plus 30 minus 2 into 50 by 60 minus 30. That is 90 minus 100 by 30 minus 10 by 30, which is equal to minus 0.33. Okay, 0.33. Now we will consider another problem that is given here. Okay, twice it is entered, and only for the sake of right, twice it was entered, but here we will consider it, that is another problem is given in the continuous form, but I am not able to enter this, but I'll explain that. Calculation of Bowley's coefficient of skewness, that is given here: 100, 200, 200, 300, 300, 400, 400, 500, 500, 600, 600, 700, 700, 800, 800, 900, 900 to 1000 is the class interval that he has given, and frequencies are 10, 15, 20, 25, 38, 7, 4, 1, and now we need to calculate the cumulative frequency, that is 10, 25, 45, 70, 100, 108, 115, 119 and 120. Based on this, as we know that median, okay, in order to find the size of the median n by 2 for continuous series, n by 2th item, size of the, that is 120 by 2, 68 item, and 60th item lies in the 75 of the cumulative frequency, hence the corresponding class 400, 500 will be the median class. If you know that median is equal to L plus n by 2 minus Cf by f into I, L is equal to 400, n is equal to 60, Cf is equal to 45, f is equal to 25, I is equal to 100. Substituting the values in the formula, median is equal to 400 plus 60 minus 45 by 25 into 100, 400 plus 15 into 4, which is equal to 400 plus 60 is equal to 460. Calculation of quartiles. Q1 size of n by 4th item, 120 by 4 is equal to 30th item. 30th item will lie in the 45 cumulative frequency, and the corresponding class 300 400 will be the median quartile, first quartile class. In order to find out the first quartile, L plus n by 4 minus Cf by f into I. L is equal to 300, n by 4 is equal to 30, Cf is equal to 25, f is equal to 20, and I is equal to 100. Okay, I is equal to 100, and that is substituting the values in the formula. You will have Q1 is equal to 300 plus 30 minus 25 by 20 into 100, that is 300 plus 5 into 5 by that is 300 plus 5 into 5 25, 300 plus 25 is nothing but 325, 325. Now if you take Q3, size of the 3n by n, 4th item, 3 into 120 by 4, that is 360 by 4 is equal to 98th item. Q3 lies in the class, that is 98th item of the cumulative frequency. Okay, lies in 100, hence the corresponding class is 500, 600 will be the median class. The Q3 formula is L plus 3n by 4 minus Cf by f into I. L is equal to 500, 3n by 4 is equal to 90, Cf is equal to 70, f is equal to 30, I is equal to 100. Substituting these values in the formula, that is Q3 is equal to 500 plus 90 minus 70 by 30 into 100, that is equal to 500 plus 200 by 3, which is equal to 566.7. Now calculation of Bowley's coefficient of skewness is equal to SKB is equal to Q3 plus Q1 minus 2 median by Q3 minus Q1. Q3 is equal to 566.7, Q1 is equal to 325, median is equal to 460. Substituting these values in the formula, SKB is equal to 566.7 plus 325 minus 2 into 460 by 566.7 minus 32.5. Okay, this is, if you simplify this, you will get 566.7 plus 325, 891.7 minus 2 into 460, you will get 920, hence 891.7 minus 920 by 566.7 minus 32.5 is equal to that is 241. 5 here we got that 566.7, and we will have Q3 is 566.7, and where 325, sorry, 325, 66.7 minus 325, you will get that is 241.7, hence 891.7 minus 920 is equal to minus 28.3 by 241.7, which is equal to minus 0.117. Okay, this is the answer that we get from the simplification. Yeah, and thank you. So with this we have concluded the class.